Hello, everyone. My name is Jacob Balagasao, and today our group is going to discuss about Chapter 2, which is all about the designing of the highway. So this presentation is brought to you by our group, Blacklist, and the members are Jacob Balagasao, Luis Janique Fado, Serafin Baldwin Kifo, Mahinay Carlito Jr., and John Gabriel Gialon. So let's get started. Consistency. Consistency is the most important single rule in the highway design. That is, by making every element of the roadway conforms to the expectation of every driver. Among the promising approaches to improve the highway safety performance is the concept of the highway design consistency. Drivers expect the highway agency to provide them with clear information and guidance through a variety of road signs and avoiding abrupt changes in the traffic as well as the road standards. If these guides and direction can be planned properly to convey one single message at a time, and if these directions will be followed smoothly and easily with undue haste or changes in speed, then the roadway facilities are considered satisfactory. Experienced highway engineers recommended that highway signs and directions should be integrated as early as preliminary layout studies. AASHTO, or is the American Association of the State Highway and Transportation Officials. In 1914, the American Association of State Highway Officials, or you can call it AASHO, was established as an association of state, territorial, and District of Columbia Highway Department and the Federal Highway Administration. The name was expanded in 1973 when the Department of Transportation was integrated into association, renaming AASHO to AASHTO, giving the officials of this agency the power to govern its operation. Engineering activities were implemented by standing committees with the task of preparing specifications, manual, and standards representing the current highway engineering practice. And AASHTO publication includes transportation, materials, specifications and test, specifications for highway bridges, geometric design standards, and numerous policy statements and guides. AASHTO publications are authoritative, meaning they are reliable. So all the information that the AASHTO published are accurate or true. Reference are made in these books and periodic manuals. The association also publishes the AASHTO quarterly reports on current highway and transportation subject, including trends in forecast and legislation. Roads and highways. Roads and highways are defined as strips of land that have been cleared and further improved for the movement of people and goods. Road. Road has somewhat broader application in usage while generally used to describe a public thoroughfare, or it can also referred as railways. Highways. The term was first used in England to describe a public road, the road built by digging ditches on both sides and heaping up the earth in the middle, creating a way higher than the adjacent land. So basically, it is a major road or bigger roads, usually in rural areas. Highway now connotes a higher state of development than road, but the words are almost interchangeable. Expressway. Expressway is a divided arterial highway for through traffic with full or partial control of access and is generally provided with grade separation and major intersection. Freeway is an expressway with a full control of access. Control of access is a condition where the rights of owner or occupants of adjoining land or other persons' access to light, air, or view in connection with the highway are fully or partially controlled by public partially controlled by public authority. A controlled access highway is a highway designed to allow traffic to safely travel at fast speed. So there are two types of control of access, which is the full and a partial control of access. Both of them has the authority to control access and exercise to give preference to a through traffic by providing access connections to selected public roads. But the only difference is that crossing at grade or direct private driveway connection is not permitted in full control of access, while in partial control of access, the control at the crossing at grade and private driveway connections are allowed. Through street or through highway. Every highway or portion thereof in which vehicular traffic is given preferential right of way and at entrance to which vehicular traffic from intersecting highways is required by law to yield right of way to vehicles on such through highway on obedience to either stop sign or yield sign erected thereon. Parkway. Parkway is an arterial highway for non-commercial traffic. So it is a wide road usually divided with an area of grass and trees on both sides and in the middle. Arterial street. Arterial street is an arterial route that carries traffic to the nearest access point or through traffic. It often serves as the most advantageous route for relatively long distance travel. So it is a road without controlled access that can carry a large volume of local traffic at a generally high speed, being below controlled access highway in the hierarchy. So these are the basic considerations in planning arterial roadways. First is the selection of the routes, studies of the traffic volume, origin of the destination, accident experience. Width should not be less than 15 meters, must carry at least one lane of traffic in each direction, should be at least 1 kilometer in length, should skirt neighborhood areas rather than penetrate them. On grids design system street, arterials are spaced at about 600 to 900 meters apart, and where accident hazard is not a factor, the minimum volume to justify arterial road is 300 vehicles per average hour during the day and 450 vehicles hourly during peak periods. And sometimes peak periods volume on designated arterial road exceeds the capacity of a two-way street. And to increase the arterial capacity, the following solutions are enforced. During peak hours, parking is prohibited on one or both sides of the streets. Parking is prohibited several meters away from each side of the road, intersections, or corners. Right turn is allowed on red signals anytime with care. Left turns are eliminated to congested intersections, and the direction of the traffic is reversed in a center lane to provide more lanes in the direction of heavier traffic flow. Collector streets. Collector streets form a smaller mesh grid pattern where passengers are picked up from service streets and carried to the arterials. So more like sumpay ni siya sa arterial roads or like a street padong sa arterial roads. So local road. Well, local road is defined as a street or road primarily for access to residents, business, or other adjoining properties. It is also defined as a road constructed and maintained by a local government. So it also refers to streets or roads na mo-accept og traffic from collector road streets or collector road or streets and distribute the traffic through subdivisions, neighbors, and business areas. So highway capacity. Highway capacity is defined as the minimum number of vehicles that are reasonably expected to pass to a given point over a given period of time, usually expressed as vehicles per hour. So under ideal conditions, one freeway lane can accommodate about 2,000 passenger cars per hour, and a two-lane road can carry up to 1,000 passengers cars per hour in each direction. So there's an obvious relationship between vehicle speed and highway capacity. As the volume of a traffic approaches capacity, the average speed is markedly reduced. Average annual daily traffic, or AADT, refers to a traffic volume or flows on the highway as measured by the number of vehicles passing a partial station during a given interval of time. It is also called average annual daily traffic if the period is less than 1 year. Volume may be stated on hourly observed traffic or estimated 38-hour volume commonly used for design purposes. This is determined by counting the total number of vehicles to cross a point in both directions on a highway during a year, and divide this value by the number of days in a year. So 365 days it divides, yeah. So next is the design speed. There is no single set of geometric standards that will apply to all highways. For every highway segment, decisions regarding appropriate control for each of the many details or requirements must be addressed individually or separately. AASHTO defined design speed as the speed determined for design and correlation of physical feature of a highway that influence the vehicle's operation. It is the maximum speed that can be maintained over a specific section of the highway when weather and traffic conditions are so favored that the design features of the highway govern. So, basic design features refers to the tightness and super elevation of curves, the sight distance, and the grade. So the design speed is basically higher than the anticipated average speed. And AASHTO recommended that the design speed to be set to the greatest degree possible to satisfy the needs of nearly all drivers, both today and throughout the road anticipated life. For economic reasons, the geometric features of a certain road sections are designed for speed from 30 to 50 kilometers per hour. Selection of the proper road design speed is one of the most important decisions to make because it sets the limit to curvature, sight distance, and other geometric features. But because of the limited funds, there is a strong temptation to reduce the design speed. And this kind of decision is very unwise because the alignment grade and sight distance up to the roadway has been constructed and paved along the landscape and right-of-way became more difficult and expensive to adjust or to correct. The AASHTO practices is to classify first the highway as rural or urban, and then as freeways, arterial, and collectors and local. Rural collectors and local facilities are classified as flat, rolling, or mountainous, although the design speed presently used is 80 kilometers per hour. Highway designers projected design speed up to 120 kilometers per hour to guarantee against future obsolescence as well as the increased margin of operating safely. The high-speed road design must anticipate future generation high-speed vehicles and advanced transportation system that may operate on many of these road alignments. Although the design speed of most highways is governed by construction costs, the concept of the relatively high design speed for freeways is regardless of cost. So they are planned for a national high-volume traffic and high-speed network. So next is the cross-section of typical highway. The cross-section of a typical highway has a latitude of variables to consider, such as the volume of the traffic, character of the traffic, speed of the traffic, and characteristics of motor vehicles and of the drive. Highway design usually adopted cross-section that is uniform in thickness from end to end of the improvement. This is acceptable on high-volume traffic road facilities, but for a low-volume traffic facilities, modifications of the features like shoulder width, in rough areas are usually employed to reduce cost. So a cross-sectional design generally offers the expected level of service for safety. And recent studies showed that a 70.20 meters wide pavement has 18% less accident compared with a pavement narrower than 5.50 meter wide. And a 7.20 meters wide pavement has 4% fewer accidents than a 6 meters wide paved roadway. Accident record shows no difference between 6.60 meters and a 7.20 meters wide pavement. For the 6 meters, 6.60 meters and 7.20 meters wide pavement with 2.70 and to 3 meters wide shoulder, recorded accident decreases by 30% compared to 0 to 0.60 meters wide shoulder and 20% compared with a 0.90 to 120 meters wide shoulder. It appears that the above difference in accident potential may not justify higher standards, particularly when traffic volume is low. So, originally, the total surface width of the roadway was only 4.50 meters, but due to the increased number of vehicles using the roadway, the width was adjusted to 4.80 to 5.40 meters. So from 4.50 meters adjust to 4.80 to 5.40 meters. So, and lately, the width of the road was standardized to 3 meters for first-class paved one-lane highway, and now 3.60 meters wide surface was adopted standard for freeway and other major traffic roadways, although there are strong demands to increase it further from 3.60 to 4.20 meters. For two-lane rural highways, a 7.20 meters wide surface is required for safety clearance between commercial vehicles and recommended for main highways. So in any example, sa cross-sectional of a typical two-way lane highways, a 7.20 meters wide surface is required for safe clearance. And for collector roadway, 6 meters wide surface is acceptable only for low volume traffic, including few trucks traveling thereon. And for local rural roadway, the minimum surface width is 4.80 meters for a 30 km per hour design speed. And for urban roadway, the minimum design width is 3.60 meters, although 3 meters is also allowed where space is limited. So these are the cross-section of a divided highways where the design speed is less than 100 kilometers per hour. And this is the undivided highways for design speed less than 60 kilometers per hour, 80 kilometers per hour, and 100 kilometers per hour. Next is a road shoulder. Road shoulder or verge is defined as that portion of the roadway between the edge of the traffic lane and the edge of the ditch, gutter, curb, or side slopes. So, kay bao naman tani sa road shoulder kay katuning kilid sa mga road. So, kasagaran road kay naman ay white strip line. So, dira, kilid sa white strip line mo na ang shoulder road. So, the importance of road shoulder. Road shoulder serves as a place for vehicles to stop when disabled or for some other purposes. Road shoulder should considerably reduces road accidents. The road capacity is decreased and accident opportunity increases if the shoulder is too narrow or nipis or omitted in the design. Shoulder should be continuous along the full length of the roadway. So continuous siya if unsa katas ang imong road mo sa nakatas sa imong shoulder. So it also adds structural strength to the road pavement. So shoulder increases the horizontal sight distance on curbs and it reduces accident potentials when vehicles stop during emergencies. So most of the road shoulders in rural areas are unpaved or dili siya sementado. Yeah, it has a width of a 60 to 120 centimeters wide, either earth field or gravel surface, that during rainy days, drivers are hesitant to occupy kay syempre maglapok-lapok man na. The policies on geometric design recommended that outside shoulders should be paved for at least 3 or 3.60 meters wide if truck volume is more than 250 in the design hour or ADT. The recommended width of left shoulder is 1.20 to 240 meters with at least 1.20 meters paved. If there are at least 6 or more lanes, the median shoulder should be 3 meters wide or 3.60 meters if truck volume in the design hour exceeds 250. For arterials with ADT less than 400, the usual shoulder width is fixed at 120 meters minimum, although 2.40 meters wide is much preferred. When the design hour volume ADT exceeds 400, the usual minimum shoulder width is 2.40, although 3.60 meters is also recommended. And for urban arterial roadway or road, similar shoulder without curb is suggested unless needed for purpose drainage. The width of the median shoulder on 4 lanes divided arterials is fixed at 90 centimeters as minimum. For 6 or more lanes, 2.40 to 3 meter shoulder width is recommended. For rural collector roadway, 60 centimeters wide graded shoulder is required for ADTs less than 400. And for ADTs over 2,000, 2.40 meters wide shoulder is also recommended. So, in this figure, muna siya ang shoulder design or mga shoulder details. So, a straight line alignment, shoulder detail with stop lane. And this figure 2 is a straight alignment, shoulder detail with stop lane, guardrail. So, guardrail, muna siya katong muna siya koral sa ali sa kalsada na mo stop sa mga car para dili matagak ang mga car, muna siya koral sa car. So, in this figure, the straight line alignment shoulder details with stop lane used as a cycle path or footpath. So, shoulder detail na naay sideline or naay sidewalk. So, in this figure, this is a shoulder detail with no stop lane, no footpath, and no guardrails. So, this figure shoulder detail is for footpath only. And the last figure is alignment in curve shoulder detail. So, naidwa ka ani. So, inside shoulder and outside shoulder. Sa outside shoulder kay paved or cementado, and the other one is stabilized or treated surface shoulder. So, the next topic is the cross slope, which will be discussed by the next reporter.
Good day everyone, I am Luijan Equipado and today I'm going to discuss about my assigned topic. So the first topic is the cross slope. So what is the cross slope? The cross slope is provided in all tangent section of the roadway. Slope usually falls in both direction of the center line of the two-lane highway, except where the super elevation of the curves direct all the water towards the inside. Here I have a picture of the cross slope example. It's basically two slopes that cross each other at the center line of the roadway. For a high type pavement, the crown or slope is often 1% to 2% range. However, steeper slope are strongly recommended. So here we have an example of the 1% to 2% slope, and as you can see here, the example of the crown road is just like the road that we can see outside that has a 2% range of slope. So what is the purpose of the cross slope or much steeper slope? The purpose of the cross slope is to reduce water on the road so that the driver can have a safe and comfortable experience on driving. The cross slope also have a shoulder. It has it can be paved shoulder or gravel shoulder. The field shoulder cross slope range from 2% to 6%, although 4% is the most common. As for the gravel shoulder, 4% to 6% slope is satisfactory, and 7 is the effective drainage for turf surface. So here I have an example of the paved shoulder and the gravel shoulder. The paved shoulder is made of cement, while the gravel shoulder is made of gravel or smaller rocks. There are also many types of road slope. The first is the cross slope, the most standard one. And the second is the parabolic slope. It's only applicable if the gutter is deep enough to support in draining water on the road, while if the gutter is not deep enough, it's advisable to use the combination of uniform slope with the parabolic curve. That's the third type of slope. And now we're going to move on for the next topic, the cut or fill slope. For the what is the cut or fill slope? From the word itself, it means cut, magbawas, and fill, magdagdag. So here I have an example of cut or fill slope. As you can see on the picture, the mountain has been cut through and has been built with the road. As you can see here in the left side of the picture, you can see the cut slope or the back slope, and beside the road or at the bottom of the road, you can see that the fill slope or embankment. Kani siya nga mountain is gibawasan sa gilid mo nang siya cut slope na gidagdagan siya para mag-support siya gi-flat in gifillan og soil then gi-flat para makabuild og road. So here, earth fill of normal height is safe on a slope of 1 and 2 ratio. Second is slope of cuts through an ordinary undistributed earth fill remain in place with the ratio of 1 and 1 slope. Cuts could be as step as 1 and 2 ratio, and sometimes 1 and 4 ratio proven to be stable. Here I have a picture of the 1 and 2 ratios example of earth fill of normal height. And now the second picture is an example of the cut through ordinary and distributed earth of 1 and 1 ratio. Now we're going to talk about the advantage of the flat side or back slope. The first advantage is with a back slope of 3 and 1 ratio or even flatter, cars could be directed to back into the road and will come to stop or continue down the slope with no risk of overturning. Second, flat fill slope are visible from the vehicle at full extent, giving the roadway a safer appearance. Third, with a visible slope for a being low and flat, vehicles could be positioned or parked closer to the edge, and on two-lane roadway, facilities parking would be farther from the opposing traffic. There are also recommended policy on geometric design. We have three. First one is the 6:1 slope ratio be adopted on embankment than 1.2 meters high and 4.1 on a higher field. Second is the 1 and 2 slope ratio is allowed to height greater than 6 meter. Number 3, the cut slope should not be steeper than a 2:1 ratio except only solid rock or special kind of soil. Here is an example of the rock catch ratio from 1 and 2 or 1 and 4. It's only applicable on a special kind of soil or rock types. The AASHTO also has a policy stipulated that where cut or field slope intersect the original ground surface, cross-section must be rounded to blend the slope with the natural ground surface. When the side slope requires embankment with a suitable retaining wall, any of the following materials could be used depending on the natural condition. Here I have a first illustration or picture of what the AASHTO policy. As you can see here, I have two example pictures of cut or field slope. The first one is the left picture. As you can see, the original ground surface has been cut and filled to build a safe and flat roadway. While the second one here, as you can see, it also has been cut and filled but has a retaining wall to support the new flat surface for building a road. The materials that could be used depending upon the natural condition for the retaining wall is first, hand-placed stone. Second, cement rubble masonry. Third, concrete blocks. 4, conventional reinforced concrete. 5, T or counter-furted design. 6, cribs assembled from timber. 7, precast concrete. 8, metal elements. 9, tied back peeling. And 10, lastly is the earth is reinforced with metal or plastic hand. So here, I have an example of cut and field slope in real life situation. As you can see in the first picture on the left, the mountain has been cut through and flattened and filled with soil so that they can start building a safe and flat road. And the second picture is an example of rock cuts or cut rocks that has a ratio of 1 to 1 and 2 or 1 and 4 slope. The number of lanes. The number of lanes in segment of highway is determined from the estimated volume for the design year AADT and highway lane capacity as expected level of service. AASHTO policy accept a dually divided 16 lanes roadway with 4 lanes in each direction for an inner freeway and 4 more lanes in each direction of the outside. Next is highway median. So what is highway median? From the word itself, it means road and something in the middle of the road. It could be barrier or flat surface with plants or signs. Yeah. For example is the road near the Park Mall. As you can see, the road there has many types of medians, and its purpose is to prevent accidents. Advantage of highway median. There are 13 advantage according to the book. The first is it is effective means of reducing highlight glares, conflict, and accident between opposing streams of traffic. Second, the median often refuse between opposing traffic stream of cross traffic, and pedestrians could traverse each stream at separate maneuver. Third, median provides available space for left turn lane. Fourth, it makes the turning of vehicles smooth and safe operation. Fifth, where space and cost permit, a wide median is highly recommended. For rural section of freeway, the 18 to 27 meters wide median is being adopted. Number 6. The policy of geometric distance states that 3 to 9 meters of median with appropriate for suburban or mountain situation. Number 7 is for rural or urban arterials, 18 meters median or wider is preferable because it allows the use of independent profile and at the same time minimize the crossover accident. Number 8. Median with 6 to 18 meters wide allow drivers to cross each roadway separately. A 4.2 to 6.6 meter median with provide protection for turning vehicles. Number 9. Curved median with 1.2 to 1.8 meter width serves up as partition separation of opposite traffic control device. Number 10. The width of traversable median should be wide enough to prevent vehicles running out of control from reaching the opposite traffic. Number 11. The 15 to 24 distance between landed edge is favored, but a specific value is not stipulated. Number 12. Cross slope of the median should not be greater than 6.1, but preferable is 10.1. Lastly, dense planting of rows hedge serve as safely crash barriers. For narrow median, you need to provide the tearing device, non-transversable energy absorbing device, non-transversable rigid barriers, and GM barriers. The tearing device is a 2 sets of double strip printed on the existing pavement, raised diagonal bars, low curving, and swallow dishes. Non-traversable energy absorbing device. The line chain link fence is 1 meter high and supported by steel posts and argument by cables at the bottom of the midpoint. Non-traversable rigid barriers are metal guardrails. And lastly, GM barriers is high non-mountain slope face concrete barriers called New Jersey. It is cast or extruded in the place or precast in a section and set in the position by the crane. And here I provide an example of highway median. It is median under structure. As you can see in the picture, it is a barrier or a wall between two roads. It also set as a protection from crashing and accident. Here is also an example of a straight alignment median in current section. As you can see here, it's covered, turf covered median, and the other one is the turf or stabilization median, and last is stabilization or turf median. It also has you call this a barrier or rails. And the third example is a centroid median with a floor plate and a covered if no parapet or has a parapet median. And lastly is also a central void with barriers. Here is an median approach and also has an arrow that shows where direction to drive. And here I have an example of the deceleration lane and insertion lane. As you can see in the picture, you can see the arrow is the arrow here is saying that it is the traffic flow and you don't have to slow down here. Well, here as you can see, there is an arrow that form a parabolic curve towards the check posted safe speed for RAM, or it is called the slow down after turning into the deceleration lane. And here are the design or the example of barrier curves. As you can see, it has different kind and shape, and also has a curve and gutter here. You can see this kind of barriers and curve in the side of the road. So let's proceed to grade line. So what is grade line? Grade line is defined as the longitudinal profile of the highway as a measure of how the center line of the highway rises and falls. As you can see here on the picture, you can see an original ground surface and a grade line. The grade line is where the engineer will be building a flat road over these mountains. So the grade line provide a line of design on where build a road. It also show us which part of the mountain will be cut off and will need to be filled up with soil. So in laying the grade line, the designer must consider the following. The first is where earthworks is minimal and consistently meeting slightly distance in relation to grade line. The economy is one of the main consideration. Second, in mountainous areas, the grade line must be considered to be balanced excavation against embankments to get minimum overall cost. Third is, in flat area, the grade line is set almost parallel to the ground surface but sufficiently above the ground or drainage purposes. Number 4. Undesirable native soil should be provided with sufficient covering. Number 5. Grade line elevation along the river or stream is governed by the expected level of water flood. So that's all for my topic. I hope you learned something. So let's proceed now to the next reporter, Baldwin Serapin. Thank you.
Vertical curve over crest. Crest vertical curves are curves that connect inclined sections of roadway, forming a crest, and they are relatively easy to design. The principal control in the design of crest vertical curves is to ensure that minimum stopping sight distance, or SSD, is available throughout the vertical curve. All vertical curves should not be shorter than the established minimum over crest. This is governed by the sight distance requirements, but sometimes a case of riding may demand longer curves than the sight distance. Some designers prefer no vertical curve to be shorter than 300 meters. The minimum curve length was suggested by AASHTO, or American Association of State Highway and Transportation Officials, to be 8 times the velocity in kilometers per hour for a distance of meters. The vertical distance from the intersection of the straight grade line to the curve is equal to 1/8 of the product of the algebraic difference in grades and the length of the curve in stations. This is called the maximum correction. The rate at which the curve departs vertically from both tangent grade line is proportional to the square of the horizontal distance from the end of the curve. The correction at any intermediate point is obtained by: number 1, multiplying the maximum correction by the square of the horizontal distance between the near end of the curve and the point. 2, divide this product by the square of 1/2 the length of the curve. The sight distance and the length of the curve can be related to each other in one of two ways. The first possibility is that the sight distance is less than the length of the curve. Alternatively, the length of the curve could be less than the sight distance. This is the illustration. Right of way. Railway right of way means a strip of land that is granted through an easement or other mechanism for transportation purposes. A right of way is reserved for the purposes of maintenance or expansion of existing services with the right of way. It is a right to make a way over a piece of land, usually to and from other piece of land. A successful freeway and expressway operations closes the roadway from direct access to adjoining property and some local roads or streets. If local traffic and land used are to be opened, it must be served by service roads originally planned as part of the main freeway. Frontage road shall be permitted to enter connecting cross streets only at a distance of at least 100 meters for rural road and 50 meters for urban conditions. So this table is the minimum right-of-way widths for rural and urban freeways at grade in meter. Stopping sight distance. Stopping sight distance is one of the several types of sight distance used in road design. It is a near worst case distance a vehicle driver needs to be able to see in order to have room to stop before colliding with something in the roadway, such as pedestrian in a crosswalk, a stopped vehicle, or road debris. Insufficient sight distance can adversely affect the safety or operations of a roadway or intersection. It is defined as the longest distance that a driver could see the top of an object 15 centimeters above the road surface, where the design height of the driver's eye above the pavement is 105 centimeters. Stopping distance is made up of two elements. Number 1, the distance traveled after the obstruction or object is seen and before the driver applies the brakes. 2, the second distance is consumed while the driver applies brakes for the vehicle to stop. The distance covered could be expressed by the following formula: D equals T M over S. Braking distance, D is equal to meter per second square over 2 GMF, and D is equal to meter per second squared over 19.6 F, where M over S is equal to initial speed in meter per second. T is detection, recognition, decision, and response initiation. GM is acceleration of gravity, 9.80 meter per second squared. F. Coefficient of friction between the tire and pavement. The highway level being flat is assumed by the preceding formula. The braking distance is decreased when traveled uphill, while it is increased when traveling downhill. The following formula can be used to express the braking distance on slopes. Braking distance is equal to MD is equal to braking distance, or M, is equal to D is equal to meter per second square over 19.8 times F plus G, where G is the longitudinal slope of the roadway, or percent grade, or 100. Uphill grade is positive while downhill grade is negative. So this table shows the minimum stopping sight distance wet road. The passing sight distance. Passing sight distance is needed where passing is permitted on two-way highways to ensure that passing drivers who use the lane normally reserved for opposing traffic have a sufficiently clear view ahead to minimize the possibility of collision with an opposing vehicle. The distance includes the distance traveled during the perception or reaction time and the distance traveled while accelerating to the passing speed. It is the longest distance that a driver can see the top of an oncoming vehicle while the driver's eye level is 1.05 meters above the pavement surface. The relationship between the passing sight distance, the algebraic difference in grades, and the length of vertical curve is represented by the following equations. L is equal to 2S minus 943 over A, where S is greater than L, and L is equal to AS2 over 943, where S is less than L, and L is length in meters. L is equal to length required of vertical curve, and S is specified sight distance. A is algebraic difference in grades expressed in percent. The design of two-lane highway of passing over crest is generally practical only on flat grades because the longer vertical curves are required to provide passing sight than stopping sight distance. F is equal to meter per second square minus SE over 9.8 rm, where meter per second is equal to meter per second, and rm is equal to radius in meter, SE is equal to super elevation. At 75 km per hour, the maximum coefficient of side friction on dry pavement, as determined by curve testing, is approximately 0.35 for smooth tires and 0.4 and 0.5 value with normal pavement. The two table shows the AAS-HTO minimum passing sight distance for design of two-lane highways and AAS-HTO recommended maximum coefficient of side friction. Road alignment. The alignment is the route of the road, defined as a series of horizontal tangents and curves. The profile is the vertical aspects of the road, including crest and sag curves, and the straight grade lines connecting them. It should be consistent. An abrupt change from flat to sharp curve and long tangents followed by sharp curves should be avoided because it will create hazard and invite accident. There are two types of road alignment. One is the horizontal alignment, and two is the vertical alignment. Horizontal alignment, it includes straight stretches, curves, etc. While vertical alignment, it includes upward or downward gradients. And lastly, this is an example of both alignments.
Good day everyone, I'm Carlito P. Mena Jr. and I'll be the one who next to report. So, circular curves. Circular curves is a segment of circle, an arc. The sharpness of the curve is determined by the radius of the circle and can be described in terms of degree of curvature. So, a vehicle traveling in a curved road is subject to centrifugal force. This force is balanced by equal and opposite forces developed through the super elevation and side frictions. Sharpness of a curve is dependent on its radius, and degrees of curve are inversely proportional with the radius. So, mo na ang formula sa degree of curve ug sa radius. Sa kaning radius kay masyang if exact kuan siya arc definitions and approximate siya sa curve definition. So the degree of curve is expressed either by the arc definitions or the chord definitions. So, kaning table degree of curves, so mano siyang sample nga pakita. Arc definitions. The degree of curve is the central subtended by a 30 meters r of the curve. And chord definitions, the degree of curve is central angle subtended by 50 meters chord. So, natay laing formula sa radius, which is sa kaning nga formula kay ato ning gamiton if exact chord definition siya. So, then, mani ang table sa sharpest permissible horizontal curves for given design speed and super elevation. The maximum allowed super elevation rate before was 0.12 but now it's 0.10, except on low volume gravel roads. The policy on geometric design recommended that first, for design speed of 50 km per hour, the normal cross slope is 1 degree to 21 or even flatter curves. Second, for a 120 km per hour design speed road, the normal cross slope is 0 degrees to 15 or flatter curves without super elevation. In each of these solution, the total side friction is less than 0.04 for an adverse cross slope of 0.02. Super elevation runoff. The super elevation runoff is the length of the roadway required to change the outside lane cross slope from a flat cross slope to a fully super elevated section. Then, mani ang picture sa super elevation. High velocity, centrifugal force, centripetal force, side or lateral friction. Then, the center of each individual roadway at a profile grade is maintained while raising the outer edge and lowering the inner edge to maintain the desired super elevation. It is done by raising up the outside edge of the pavement with relation to the center line until the outer half of the cross-section is flat. So, mani ang figure sa super elevation of curves. So, mao na yung table guys sa suggested minimum length of super elevation runoff for 2 lane a 3.60 meters lane. So, makita na to sa picture. Then, H2 American Association of Highway and Transportation Officials recommended the runoff length to vary both with super elevation rate and the design speed, but with minimum state of appearance and comfort to riders. A roadway that lies in a cut where the grade line is nearly flat may create sag by lowering its inner edge. This may not drain surface water. It is recommended that 60% to 80% of the runoff from an elevated alignment should be on a tangent. It's possible to achieve super elevation by raising the outer edge of the alignment twice the usual distance. So for wider roadway, the length given on table 2.9 should be increased as follows. First, if 4 lanes, individual value increased by 50%. Next, 6 lanes, individual value increased by 100%. Widening of curves. A provision for a wider roadway is necessary on sharp curve for 2 lanes pavement under the following reasons. First, to force the drivers to shy away from the pavement edge. Second, to increase the effective transverse vehicle width for non-tracking of front and rear wheels. Third, to give additional width due to the slanted position of front wheel to the roadway's center line. The last one is for a 7.20 meters wide roadway, an additional width of 30 centimeters is necessary on an open curve highway. Reverse circular curves are seldom used on modern highways, but reverse curves that are provided with proper length easements between them are acceptable. If no easement curve is allotted, curves on opposite direction should be separated by tangent several meters long. Roads with compound curves that change abruptly from one sharpness to another confuse the drivers and in turn they shift position within the lane and sometimes veer out of it. Compound circular curve of different rada is considered as poor design, especially in rural areas. H2 recommends again that the radius of the flatter curve for rural highways should never be more than 50% greater than the of the sharper one. For urban intersection, this is easement curve is considered, which introduces the changes in radius gradually. Super elevation changes along this transition section. Islands. An island is defined between traffic lanes for control of vehicle movement and for pedestrian refuge. It may range from an area delineated by barrier curve to a pavement area marked by paint. On at grade intersection in which traffic is directed into definite paths by island is termed as channelized intersections. Island is included in the design of intersections for the following purposes. First, separation of vehicular flows. Second, separation of conflicts. Third, reduction in excessive pavements areas. Fourth, reduction of traffic and indication of proper use of intersections. Fifth, arrangement to favor a prominent turning movement. And the last one is location of traffic control devices. These are usually the main cause of confusion and accidents, which led to road accidents. When cross traffic meets at flat angle, head-on collision could be more serious. A right angle at 75 degrees to 105 degrees is most favorable, giving the driver that opportunity to assess or calculate the position and speed of oncoming vehicles. By channelization, funneling is also effective in preventing overtaking and passing in conflict areas. A well-studied super elevation is an important adjunct to channelization that regulates the vehicle speed, and first, prevented turns are prevented. Next, refuge may be provided for turning or crossing vehicles and pedestrian. Figure 226, general types of shapes in island. We have the angle between intersecting streams of traffic can be smooth and favorable. Prevented turns may be prevented. Speed of vehicles controlled over approaching intersections. Funneling vehicles into narrowing opening prevent overtaking and passing conflict area. And refuge provided for turning vehicles. Then the last, drivers commanded to merge into moving traffic streams. The third one, by channelization, refuge may be provided for turning crossing vehicles and pedestrians. The fourth one, the drivers has to face only one decision at a time. Hence, conflicts can be avoided. The last one, it provides location for the traffic control devices like signs, signals, and refuge for pedestrians. Types of interchange. The types of interchange form of freeway interchange requires selection, the confirmation that is best suited to a particular situation, and demand. The functions of freeway interchanges are: first, to provide separation between two or more traffic arteries. Second, to facilitate the easy transfer of vehicles from one entry to the other or between local roadway and the freeway. Diamond type interchange recommended where the freeway crosses non-freeway arterial, and the clover leaf type interchange recommended for freeway and arterial intersections. Intersecting arteries are separated and free of intersections. The diamond interchange is the most cost-effective form of interchange. Objections to the cloverleaf interchange design. First objection, it requires large area of land. Second, at higher design speed, more time is consumed just to traverse the longer loops. Third, vehicles making left turn execute 270 degrees right turn and travel greater distance, becoming unpleasant and hazardous due to the sharp curves and steep grades. Last one, vehicles leaving the curved loop in one quadrant, whereas those entering the adjacent loop from the true roadway. Under this type, waving and merging movements are separated. Alternative cloverleaf design with collector distributor 2 is recommended for 1 or 2 through streets if added light paving and structures can be justified. When freeway meets freeway, where traffic movement is heavy, interchange provided with directional left turn in all 4 quadrants. Figure 227 types of freeway interchange. We have Y-type interchanges and T or trumpet. Then figure 228 types of freeway interchanges. We have diamond interchanges, partial cloverleaf, cloverleaf. Figure 229 channelized interchanges. We have directional interchanges and through freeway with rotary flyover with roundabout. Then the last figure 230 fully directional interchanges. We have 4 level, A, B 3 level, C 3 level also. Figure A roadway at 4 levels is appropriate where land is very expensive. B and C is more open design common in 3 level of roadways, require mid control or grades and side distance.
Good afternoon, everyone. So today I will continue our topic and I will talk about highway and intersection upgrade. So highway and this intersection upgrade. So it is stated that all highways except freeway have intersections at grade. The intersection area is considered to be part of connecting road. So dapat yun di magawa magkita-kita og highway nga way intersection, di ba? So part naman gina sa highway ang mga intersections. So in this area, all crossing and turning movements occur. For right angle intersections with little traffic, the street sign is more than sufficient. So para yun aning example, right angle na siya kanang murag simple lang gyud nga intersections ba usara ka linya ang mosulod. So dari dili na ta kinahanglan og mag-channelize diri. So ang paigo na kaayo ang magbutang lang ta og street sign, okay na kaayo. So for number 2, for Y intersection or other related conformation where vehicles meet at unfavorable angles, it may require channelization. So og diri kanang basta magsugod na gid ka-complicated ang karsada kanang daghan na kay silang mga daghan na kay mag-abot nga bisa gikan from different nga giagian magabot sila at certain point so mulibog na gid asa driver maglibog na gid kag asa man day kaani dapat muliko. So kinahanglan ta mag-channelize diri. For example, aning mga Y intersection, kinahanglan ta mag-channelize diri kay para tuloy-tuloy ang daloy sa katong karsada. Same dari mo pa ni ang mga Y na kinahanglan nato i-channelize. Ani. So number 3, the flare design will involve the following. Letter A, widening the entering traffic to allow deceleration of the car and clear of through traffic. B, widening the leaving lanes to provide acceleration and merging from traffic lanes strips. So kaning parallel type di ay kay kabantay mo before siya mosulod sa iyang linya kay na siya murag gamay iyaha nga kasudlan kay para continuous ang iyahang dagan. So before gyud siya mo merge sa main nga traffic, diara siya mo agi kaning gamay nga karsada in order to merge continuously. The next, the number 4 is intersections must accommodate large truck and the radius of all curves must be sufficient enough to accommodate them. So, dili kay makaingon tag must accommodate large truck kay syempre dili ra gyud mga auto ug mga motor ang pwede moagi diha, pwede gyud moagi ang mga dagkong sakyanan like mga prime movers o mga cargo truck. So, it must accommodate these large trucks. So a careful traffic count and projected future improvements precede the design of critical sections based on the data gathered on traffic count. A lane capacity could be determined, including the number of lanes to be constructed. So the lane capacity kuno could be determined, including the number of lanes to be constructed. So my next subtopic is freeway entrance and exit. So a single lane on ramp vehicles flows into the outer continuing freeway lane. The design is either a tapered blending to the lane or an auxiliary lane parallel to through the lane. In either case sufficient, the lane is required to allow the vehicles to accelerate and merge into ongoing vehicle streams at speed near to the freeway. So for example, kaning parallel gid siya kanang naa siya specific nga length o kaning 30 meters before siya mo merge sa into traffic diagonal. However, kaning sa tapered kay mura siya nahimong curve gani nga mulhaw siya gamay o gamay na lang ang iyang kwaon para sa iyang igsulod niya sa iyang merge niya sa traffic. So 30 meters dari sa parallel o sa tapered kay na 180 meters o niya corresponding nga length niya of ramps in meter nga naa diri sa kilid. Same pod sa exit, nag-entrance ta, same pod sa exit, vehicles leaving the freeway need the distance to accelerate and clear of the flow ongoing traffic in a situation where one lane could not meet the traffic demand. So two lane exist is necessary. In that situation, an auxiliary lane must be added to the freeway at least 800 meters before the point of exit. Even with one lane exit, an auxiliary lane is necessary for it reduces confusion and congestions. So, ani kay, for example, mo biya na ka sa freeway, so dapat layo palang gidaan, mo anhin na ka sa imong lane nga para mo lane na kadaan kung asa ang para exit sa freeway. Mura ra gud nag sa kanang sa SRP magani makabantay gyud ani sa SRP kanang na ma-channelized man na SRP na dito nakaputang sa ubos sa karsada nga na to Cebu City nya na to SRP ay dili day na nakabutang dito to Cebu City nya na puto sa usa nga lane nakabutang pod to galing to U-turn slot niya sa usapod nga lane ay to si LX Bridge. So ana na siya kay para dili ma-confuse ang mga motorista. So railroad and highway separation. So the main question asked in a railroad and highway separation is where one is to go over the railroad or the highway. So unsa man gyud na sa babaw ang railroad ba or ang highway ba? So what are your ideas? So let's get into it. If the highway is to go over the railroad, the structure itself is lighter and the highway load is much smaller than the railroad loads. With regard to the vertical clearance height, the railroad requires a minimum of 7 meters as against 4.8 meters clear distance above the highway. So, og ang agyanan ko no sa trend na sa ilawom sa highway, syempre okay ra kay siya kay ang highway mas gaan siya. It is the structure itself is lighter and the highway load is much smaller than the railroad. Kumpara nato sa train. Yeah, with regards to the vertical clearance kuno kay if ang train na sa ilalom dapat mag-need siya at least 7 meters ang iyang vertical clearance gikan sa highway o sa railroad nga karsada. However, if ang highway na ilawom niya ang railroad na babaw, special provision is required for removal of rainwater that falls within the opposing area. If the groundwater is high in the vicinity of the crossing, the roadway must be sealed against leakage and be made heavy enough to prevent it from floating. So, yung aning situation, like nasa babaw ang iyang railroad, special provision kuno is required for the removal of rainwaters. Kumpara sa if mailawom ang railroad, dili ta manginahanglan ana. So, for the last topic of our group is the bicycle lane. So, bicycle lane is now becoming popular due to necessary. So, bicycle lane is now becoming popular due to energy crisis and traffic problems. It requires a separate road for the riders that are entirely separate from the vehicular traffic. For example, ano na sa ubos magkita maginato. Og bisag kita gud sa Cebu City makakita mo kitang mga bike lanes. However, naatay bike lanes pero murag di ra magamit kay gihimo mang parking lot og naay mga motor dito pod moagi. So naatay law nga bike lanes pero ang mga tao may mo problema kay di mo sunod sa law. So the design lane is 20, the design speed is 20 to 30 kilometers per hour for flat section. The width is 2 meters minimum for a two-way travel at a grade of the lane is 5% maximum on short distances. So the minimum requirements for a two-way bicycle lanes is 2 meters. So tag 1 meter kada tao. So 1 meter padong dito o 1 meter padong dire makita na to dire sa image nga naa sa kilid. And that is where our topic ends. Hope you understand our topic from the first topic discussed by Jacob Rel de Casaho and up to this final topic. Thank you for listening, and this is all.